All right. We are going to be learning about lesson 2-6 here. So what we're going to be doing is we're going to be taking everything that you've learned about proportional relationships and basically putting them into word problems to determine whether a relationship is proportional and to figure out like what the equation would be for that, and to go into kind of, finding out some unknowns after that. So the I can statement, the objective for today is I can determine whether a relationship is proportional and use representations to solve problems. So make sure you are writing this down. If you need to pause the video, pause now. All right, so just remember, how can you tell if a situation can be solved using a proportional relationship? We can tell a couple different ways, okay? We can tell if the situation is proportional, meaning it has a constant of proportionality. So what that often means then is that we are dealing with if we're looking at the formula, okay, it means that we're in the y equals kx form, where k, and we're going back to where k is the y divided by x, okay? So those are both proportional situations, okay? We can also look at the graph. If we have a graph and it goes through 0 and it's a straight line, that would also be considered a proportional relationship. So make sure that you are, as we're going through these examples today, that you're remembering those from past lessons. So we're looking for things that have a constant of proportionality, so where that k is consistent as we divide down, okay? And that you can put the information in that y equals kx, and if we were to graph it, it is that straight line coming from 0. Okay, so let's look at a few examples. So the first example we have, Martin is 6 years old when his sister Cassandra is 3 years old. How old will Martin be when Cassandra is 6 years old? So I think a lot of us could figure this out pretty quickly, but just for for the sake of this, we're going to look at it in a very math way. So right away, we are looking at Martin's age and Cassandra's age. We know that they are 3 years apart, okay? How old will Martin be when Cassandra is 6 years old? Well, we're going to take that same, there's a difference here of 3 years. So we could say we're subtracting 3 here to get from Martin's age to Cassandra's age. So the same thing would happen here. So if I were to take Cassandra's age, I know that Martin would end up being 9 years old. Okay, when Cassandra is 6. Now, the big question is this a proportional relationship? Well, if we look at it the way we want to look at it here with dividing our y divided by our x, if we make Martin x and Cassandra y, if we were to divide 3 divided by 6, and then down here, 6 divided by 9, will we get the same answer? No, because 3 divided by 6 is 0.5, and 6 divided by 9 is 0.6 repeating. So is this a proportional relationship? No. No, it is not. Okay? All right, let's look at another example. Okay, in this example, it says a florist makes bouquets that include 50 white flowers and 7 red flowers. If the florist orders 1,050 white flowers and 140 red flowers, there will be leftover flowers. How can the florist adjust the order so that there are no leftover flowers? So essentially what we want to do is we need to figure out the concept. We want the situation to be proportional. So we need to make the situation proportional. So what I'm going to do is I'm going to make my white flowers X. So I'm going to say that's the white. Okay. And I'm going to make my Y the red flowers. Okay. So if I take the information that they state right here, I've got 50 white flowers for every 7 red flowers. So the first thing I want to do is I want to figure out my K, my constant of proportionality. So I'm going to say if I have 7 and I'm going to divide it by 50. Okay, so 7 divided by 50 is 0.14. So I'm going to make my formula here for this situation y equals, because I'm turning this into the y equals kx form, I'm going to say y equals 0.14x. Now, by doing that, what I'm doing is I'm creating a situation where I can plug information into the formula here to find out how many flowers I should have, okay? So what I'm going to do is I'm going to, let's say we have the florist orders, if the florist orders 1,050 white flowers and 140 red flowers, there will be leftover flowers. How can she adjust her order? Well, let's pick one. So I'm going to pick the red flowers, okay? I'm going to say the red flowers, which is my Y, and I'm going to order 140 of them. So what I'm going to do, and I'm actually going to erase this here just so we have a little bit more room. So we're still dealing with this Y equals 0.14x. And just as a reminder, I'm going to make my white flowers my X and my red flowers Y. And I'll just put that up there so you guys can reference. So what I'm going to do is I'm going to take this 140 red flowers and I'm going to plug it into my formula. Because the red flowers I've determined are Y, I'm going to plug it in where Y is. So I'm going to go 140 now equals 0.14x. Now I have an equation that I'm going to solve for. So I'm going to divide both sides because I want to get x by itself by 0.14. That goes away. If I do 140 divided by 0.14, I'm going to get 1,000. So I can adjust my flower order so that if I have 140 red flowers, I'm ordering 1,000 white. Okay? We could also do this the other way. We could also say, okay, again, I have my, this is X, this is Y. I still have my same constant of proportionality situation, but let's say instead I want to order that 1,050 white flowers. So I'm going to plug that in for X this time because, again, the white flowers are my X. So I'm going to say 0.14 times 1,050 to figure out how many red flowers I should order. And if I do that and I multiply, I would order 147 red flowers. So there's two different ways to look at this problem because they aren't specific about whether or not they want to stay with 1,050 white flowers or 140 red flowers. But either way, either one you pick, they're going to have to either adjust their order and, in this case, add 7 more red flowers for it to stay proportional, or in the other situation, delete 50 white flowers to keep that situation proportional. Okay? All right. Let's look at another example. So in this one, we say we have the ratio of collectible cards Deshawn owns to cards that Stephanie owns is 5-2. Okay. Right away, we have a ratio here. So I'm going to say 5-2. Stephanie has 36 cards. How will the ratio of Deshawn's cards to Stephanie's cards change if they both sell half their cards? Okay, so first of all, hold on. Yes, I'm still here. First of all, I need to figure out how many flowers Deshawn has if Stephanie has 36 cards. Or yeah, how many cards Deshawn has if Stephanie has 36. So right now I have Deshawn on top, Stephanie on bottom with how many cards they have with the 5/2. So I'm going to keep it consistent. If you remember, you always have to keep it consistent. So I'm going to put Stephanie on the bottom here with 36, and I'm going to solve for x. I'm going to cross multiply, divide by the lonely guy. So if I do 5 times 36, I get 180. Divide that by 2. I have 90. So in this case, x equals 90. So now we have 90 flowers. And I'll say, okay, Deshawn has 90. Stephanie has 36. But are we done? No, it's asking us how will the ratio of Deshawn's cards to Stephanie's cards change if they both sell half their cards? Well, if we have both how much they both have, which in this case we'll divide by 2. So 90 divided by 2 would be 45. 36 divided by 2 would give me 18. Essentially what I'm doing here is I'm creating a table of information. And I'm trying to determine, will it stay consistent? Will I still be proportional here? And the answer is yes, we will stay proportional. Because if you look at it this way, if we were to do 36 divided by 90, you get 0.4. If you do 18 divided by 45, you get 0.4. If we were to do the 2 from the original thing, the 5 to 2, if we were to do 2 divided by 5, I also get 0.4. So how will the ratio of the chain cards change? Well, it's proportional, so we would just say proportional, or yes, they're proportional. Okay? All right. So what's going to happen today when you guys go into your IXL, when you do your IXL today? You're going to have, each question is actually going to be like a 3-part kind of situation where you're going to be dealing with the same situation, just in 3 different situations. So I want to show you guys an example of what that looks like, just so you guys aren't super confused when you're going through and doing the IXL today. So here's an example of like step 1 of the 3-part kind of question. And they do count each one as a question. You get points for each thing. It's not like it's a 3-parter type situation. So Norma, in this case, we have Norma and her dad share an intense love of baseball. Every weekend, they go to the batting cages to practice hitting. Norma's dad buys tokens for her to use in the batting cage. There is a proportional relationship between the number of tokens Norma uses, X, and the number of pitches thrown by the pitching machine, Y. Okay, so they're already determining X is tokens, Y is pitches. Okay? If Norma uses 2 tokens in the batting cage, the pitching machine throws 26 pitches. So that means if I were to set up like an XY table here, we have tokens would be 2, pitches would be 26. We want to write an equation for the relationship between X and Y. So I'm going to divide my Y divided by my X to get 13. That is my constant of proportionality. So when I type it in here, I'm going to say 13X. Don't forget the X because it's the Y equals KX form that we're looking at here, that form. Okay? All right. I have to erase that. Submit. Okay. So that's like part 1. Okay, creating the equation. So now we have our equation. You can see they listed on here. The equation that models this relationship is Y equals 13X. Same situation as before. Okay, we're still dealing with Norma and her dad and the pitches and the tokens. But now it's going to ask you to use this formula for some information. So it says, how many tokens does Norma use to get 39 pitches? Write your answer as a whole number or a decimal. Okay, so we've already determined that the tokens is X and that the pitches are Y. The information they're giving us is 39 pitches, which means I'm going to plug in 39 into my formula for Y. So I'm going to say 39 equals 13x. Now I have to solve. So I'm going to divide by 13. Divide by 13. That goes away. 39 divided by 13 is 3. So tokens, she should have 3 tokens. Okay? So now they're going to give you kind of the opposite situation. In this case, they're asking how many pitches does the machine throw if Norma uses 6 tokens? So before we were talking about pitches, now we're talking about 6 tokens. So I'm going to plug in, I'm still using the same formula. I'm going to plug the tokens, because again, tokens are X, into the X. So now I have Y equals 13 times 6. So if I do 13 times 6, Y is going to equal 78. Okay. So I'm going to type that in here, 78. There we go. Done. Okay. So that's what you're going to be doing today. You're going to be going through, you're going to have to come up with the constant proportionality equation with that Y equals KX. Then you're going to have to use that formula to find some information based on like information they give you. Make sure you really pay attention to what is X and what is Y in each situation. Okay. All right. So that's all I have for you guys today. Your IXL is VKK, and that's all I got. Thank you.